Here's I have example of the furnace with ignition like an igniter. What do we have here? We actually should have here the incoming power, 2 wires for 120 volts incoming power. Then these incoming wires connected directly to the control board. On control board we have here one more like connector which is connected to the transformer. With this transformer it's transforming 120 volts AC to 24 volts AC, and this control board has 2 circuits. One is 120 volt circuit and another circuit is 24 volts AC like alternate current circuit. Okay, low voltage circuit and high voltage circuit. Some devices on this furnace use 120 volts, some devices use 24 volts, but it's like doesn't matter. Okay, here's where we have connectors like I said, W, common could be not using, doesn't matter. When you turn on the power on your wall thermostat, you will energize the relay on thermostat which connecting W and R. When you in itself wanna make a heat, like warmer your house, you energizing, you actually bypassing W and R. What happens, like I said, the next happened, here's I have a relay which connected to the control board, and this is energizing relay which sending power to inducer blower wheel motor, and this motor start running like that. It's starting running like that. Then, because here's to the heat exchange camera, to the room for the heat exchanger. When you turn on the thermostat and requiring heat, here's a bypassing 2 terminals, W and R. Here's the incoming for the R terminal, 24 volts AC. Okay, like I said, it's using like the control board has 2 circuits, low voltage and high voltage, 120 volts and 24 volts. For the 24 volts circuit, here's also have the control board have the fuse for 3 amperes. Okay, when you turn on the heat on the thermostat, the first thing what will run, it will run the relay on control board which getting power to the inducer motor. When you turn on this thing, the W and R terminals on control board, actually on wall thermostat, it will run immediately the inducer motor. The next thing, because it's increasing the pressure inside the room, whereas we have like a heat exchanger, it's actually right here. It's here's I have like a pressure switch connected to this heat exchanger collector. And because it's a sensing that like a decreasing because it's removing the air from the heat exchange collector. It's this pressure switch is usually on this model is normally open. It's closing this circuit. This circuit also connected together with safety thermostat. On this model it's right here and right here, because when that thermostat it's responsible for the safe furnace, like against the overheat. Because when the furnace is running, for example, your heat exchanger gives too much heat for the body, for the frame of furnace, then this heat will reach these safety thermostats, and it will just cut off the whole circuit for the running for running the furnace. It just will not turn on the whole furnace. It will try to run multiple times the inducer motor, but the circuit for the pressure switch will be turned off. And also you will probably able to see the issue at the control board. Here's I have a small indicator which will say you the issue, what could be wrong, like a pressure switch, like an issue or something like that. In this case, it could be just not running the blower wheel motor, or something wrong with blower wheel inside this inducer motor. I mean inducer case, because it couldn't like run out the carbon monoxide and carbon dioxide. Okay, when this pressure switch is actually the third step already, it's coming the that signal, what the pressure switch is closed. This signal is going to the control board. The control board will see what the pressure switch is closed. The next relay will send the 120 volts power to the igniter. Igniter will ignite, like it will getting red color, you will see that, or like a yellow, and then the control board, depend on the model, could sense the changing of resistance of this igniter, or just will run this igniter by time, like a 10 to 30 seconds. It's running like a 30 seconds. It's ignite the igniter. Then after 10 or 30 seconds, the control board will open send the power 24 volts AC to the gas valve. This gas valve has just one solenoid, which will open the main valve, and whole pressure of gas will go through this black pipe to gas injectors. Because inducer motor is consumed the oxygen from air, this air is going through here, for why here's always you should have a cover and with holes, and this space should be always with some like a gap, or like a 10-15 inch, or like your door. If you will have your furnace on the closet, you should have the door with grills for more air coming to your furnace, for like a heat process. Alright, then because the gas is running to the gas injectors, and your igniter already is ignited, it's red, it's hot, the gas will be getting flame. This thing will be running like a very high temperature flame, and here this wire, actually here we have a flame sensor. This flame sensor, it's will send the small amperage electricity to control board, and it will say to control board, keep running on the gas valve. The gas valve like will turn off automatically when it will not sense the flame, or will be something wrong with flame, just like if it will stop the inducer motor, because it will not suck the airflow through the heat exchanger. It will stop the process of the burning. Okay, because it's for example, like let's imagine it's running the flame, the heat exchanger getting hot, and here inside, just here, actually this thing is called the high limit switch. It's sensing the temperature inside the heat exchanger, and just actually we have a collector, and it's sensing the temperature inside the heat exchanger camera, the room. And when, for example, they usually like it's reaching 120 Fahrenheit of hot air temperature, and it's usually this high limit switch, it's like running like a thermostat, normally open thermostat. It will close the circuit. This circuit will understand, the control board will understand what the high limit switch reached needed temperature, and will close circuit for the relay. This relay is connected to the blower wheel motor, and the blower wheel motor will start running move air through the furnace. Okay. The next thing, it will run the running process. It will run. It will heat your house, and when the thermostat will reach needed temperature, for example, you set your temperature for the heat to 75 Fahrenheit, the thermostat will send the warm inside the house. It will turn on like a cut off the circuit between W and R. What will be happen? It will be shut down the power to the gas valve, because here's a heating 24 volts actually. Then it will, after like a few, probably sometimes it's shut down this inducer motor immediately, but by normally it should running a little bit, like probably 10-15 seconds, and then should off the inducer motor too. After that, because the air handler, like blower wheel motor, still running, and it's removing the heat from the heat exchanger, because heat exchanger is still hot, it will run still the blower wheel motor, because high limit switch still hot. When, for example, usually that high limit switch has like a sign 120 minus like a 15 Fahrenheit. That will be means that when the high limit switch will reach 105 Fahrenheit, it will turn off the relay on control board, which is running the blower wheel motor. That's it.